Hi everyone, in this lecture we are going to go over chapter 5. Chapter 5 covers the loops and files. We in the previous chapter we talked about conditional statements, the different types of conditional statements, if else, if else if, and then nested if. And in this lecture we are going to take one more step or further step and cover the loops. So why do we need the loops? Well, the loop is when you execute a program or a statement or a block of statements a certain number of times, many times, either a fixed number of times or as long as the condition, a given condition is true. So let's see how it works. And then there are different types. We will cover the for loop, the while loop, and do while loops. Okay, so let me switch to Visual Studio and then have examples how the loop works. So let's say, for example, I want to print a statement. Let's say I like C++. Okay, so if I run the program, it's going to be printed only one time. As you can see right here. Okay, now what about if I want to display the same statement, let's say 5 or 10 times? So I'm going to include a for loop. So I start with for, lowercase, F-O-R, and then the parentheses, just like in F statements, you have parentheses right after. It's the same thing. And then you have three components, three things that you have to have. First thing is the starting point, because the program will keep counting as long as you know the condition is true. The program keeps executing. So you have to tell the program where to start and where to end. Let's say I'm going to start from 1 and keep counting 2, 3, 4, 5, 6, 7, 8, 9, 10, stop. Once you get to 11, then you stop. So you tell the program three components. The starting point, I can start from 1, I can start from 0, or from any number I want. But the most common one is 0 and 1. So I'm going to start from 1, let's say all the way to 10. Here I'm putting the condition. I'm telling the program as long as the number is less than 10 or equal, then keep executing this statement over and over again. And then by how much? Usually we go by 1. That means go 1, 2, because sometimes you may skip. You may go by 2, you may go by 3, by 5, by 10, depending on the situation. So here all what I'm doing, I'm telling the program, keep counting how many times this statement will be executed. Start from 1, and go all the way to 10. Once you go to 11, 11 is not less or equal than 10, so the program will automatically stop. And we are going by 1. This is called incrementation. And we can use also decrementation if you want to go backward. So now if I run the program, see, I have the statement 10 times. 1, 2, so the I keeps increasing. Now let me show you the value of I so you can understand what I'm talking about here. Let me put I here, and then maybe like a little space there. All right. So now you can see the number, the value of I keeps changing. So when I run the program, you're going to see it starts from 1, I like C++, 2, I like C++. See that? So it keeps counting 2, 3, 4, all the as long as the number is less or equal than 10, the program keeps executing the same thing. I like C++. Once you get to 11, because 10 plus 1 is 11, so before executing, the program will check the condition. Is the number less or equal than 10? No, so that's false. That's when it's time. That's when the program knows it's time to stop. I hope this is clear. Okay? So it doesn't really matter we start from 1. If I start from 0, then how many times I have? I have 10 plus 1 because 0 also is a step. Okay, so that's going to be 11 times. So if you run the program, it's going to go from 0 all the way to 10. So that's 11 times the statement is executed. Okay, now I can print the number itself. As you can see right here, I. So from 0 to 10, so you're going to see from 0 to 10. See that? Instead of printing I can print I times 2. That means whatever I is, multiply by 2. So 0 times 2, 0. 1 times 2, 1, and so on. So whatever you have in the statement, it's going to be executed a certain number of times. So 0, 2, 4, by we can multiply I by 2. Or I can multiply I by itself. I by itself. So that means square. So it's going to be 0 square, 1 square, 2 square, 3 square, 4 square, and so on, all the way to 10 square, as you can see right here. Or I can put the number and the square next to it. I can do that. So I'm going to put I, and then I'm going to put like a little separation, say, to separate them, and then I'm going to put the square next to it. So now you can have, um, you can compare I and I's, because you can see right here 0, 0, 0, 1, 1, because 1 square is 1, 2 square 4, 3 square 9, and so on. Okay? So sometimes I may not, or I may decide to go by 2, sometimes for whatever reason. So instead of going by 1, I can go by 2. So I put plus equal to, that means keep adding here. So here I have I. So now I'm going to get start from, we always start from the initial value 0 because that's included as long as the condition is true. Excuse me. So if I run the program, it's going to show 0. Now I'm not going to go to 1 because it doesn't say plus plus or plus equal 1. And by the way, plus plus and plus equal 1, it means the same thing. Or you can put I equals I plus 1. All these three are the same. All what you are doing, you are adding 1. But it's so common that we use plus plus because it's faster and it's easier to remember. Okay, so now if I put plus 2 plus equal, don't get confused. Sometimes people they may put something like that. So if you are doing this, now it's like you are saying I equals 2. You are not adding, you are just saying, because plus, it's optional, right? When you have a like a number 5, you don't say plus 5, okay? It's just 5. So here what you are doing, you are just assigning 2. So it's going to stay 2. So you have to be careful that you start with the plus first, then equal. That means I'm adding 2 to I. So now when I run the program, you're going to see that it shows 0, 2, 4, 6, 8, 10. Now, the next value is 12, but because 12 is not less or equal than 10, that's why it's not printed. Or I can go, let's say, from 0 to 100, but I'm going to go by 10. I can do that. See that? So that's going to show 0, 10, 20, 30, 40, 50, 60, all the way to 10. Now, if you remember, when we talked about the if statement, I said, and I emphasized the importance of the significance of using braces. I said if you don't use braces, the program may assume that only the first line is part of the loop or the if statement. So if I try to use something else, let's say cout I square, for example. So now here you may think that I'm doing both of them, both statements are part of the loop. But look what can happen. When I run the program, let me see, I messed up here. Yeah, so here what happened is because I did not use the braces, so the program considered only the first line to be part of the loop, which means the second I is not even recognized because I is a local variable, it's inside the loop, so it will not be recognized. So it's going to have only the first line. So to avoid that problem, all what you need to do is just use the braces. So use the brace. Now both statements are part of the I. Now you should have no problem printing the program. See that? 0, 0, 10, Now, so because here I'm going by 10, that's why it shows the square. So be careful again that you use the braces all the time, just like what we did with the if statement. Make sure that you are using, even if it's one line, so make it a habit to use the braces to avoid any confusion. Okay, and then also we can go backward. Okay, you can go either forward or backward. For example, I can go from 10, and then in this case, I'm going to switch the symbol. So instead of less than, I'm going to use higher or equal than, let's say 1. I'm going to go from 10 to 1, but backward. And then minus minus. So I'm going from 10. Is 10 higher or equal than 1? Yes. So print 10. And then subtract 1, minus minus. And then go to the next value. It's 9. Is 9 higher or equal than 1? So you have to check, make sure that this condition is true before the execution of the statement. So as you can see, it's the same thing, but we are going backward. You can also subtract. You can say minus equal to. That means I'm going by 2, but backward. See that? I can also multiply. So let's say I want to go from 1 all the way to, so when we are going forward, we use less than. If you are going backward, we use the higher than. Be careful because this, if you don't put the right symbol, one of two things will happen. Either you're going to have an infinite loop because the program keeps going on and there is no way to stop the program because that condition never changed to false, or it may not run at all. Why? Because the condition is false to begin with. So you have to be careful. So here I'm going forward. It doesn't really matter if I'm adding or multiplying. I'm going forward. I'm going to put less or equal, let's say 100. But instead of adding, I'm multiplying. So I'm going to go multiply by 2. That means I'm going to start with 1 times 2 times 2 times 2. Or as long as the number is less or equal than 100, then just keep printing I. So if I run the program, look what can happen. Basically, the multiples of 2. You see that? 1 times 2 times 2 times 2 times 2 times 2. So you keep going until, now the next number after 64 is 128. And that 128 is not less or equal than 100. So that's why it's not printed. Okay? So be careful about that. Okay? I can also use the division, but if I'm using the division, I'm going backward. So let's say I'm going from 100. I have to change the symbol to higher than all the way to 1. And then I'm going to divide, let's say, by 2. So I'm going from 100. 100 divided by 2 is 50. 50 divided by 2, 25. 25 divided by 2. Remember, there is no decimal when you divide an integer by integer, so you get only 12. And then 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 by 1. So 1 divided by 2 is 0. So 0 is not higher or equal than 1. So it will stop. So as you can see right here, we're going to get 100, 50, 25, 12, 6, 3, 1. Now, let me ask you this. What happened if I use 0 here? What do you think is going to happen? So think about it. I gave you like a few seconds to think about it. I'm not going to run the program. Okay, what's going to happen if I change that 1 to 0? 100, 50, 25, 12, 6, 3, 1, 0. 0 divided by 2, 0. Divided by 2, 0. So you're going to get stuck with 0. So this is an example of an infinite loop because there is no way the program is going to exit unless, as long as the number is higher, but when you get to 0, it keeps saying 0 because when you divide by 2, it keeps 0. So this, if I run the program, it's going to be an infinite loop. So if you are using your computer, it may crash your computer. That means you may run out of memory, and then it will freeze the computer or something like that. Okay, so be careful about this situation when you have an infinite loop. Now another example, what happened if I use, let me give you an example. What happened if I started from 1, okay, and instead of changing that, putting less, I forgot, and then I put, let's say, higher than, and then I put I plus plus. What happened? So my intention is to print the numbers from 1 to 10. But look what happened here because I changed it from less than, I'm supposed to use less than, and by mistake I put higher than. What can happen is 1 is 1 higher or equal than 10? No. So nothing will happen, nothing will be printed. So if I run the program, there's no error, it just nothing will be displayed. You can see because the condition is false to begin with. So as you can see, there's nothing wrong with the program. There's no error whatsoever. It just the condition is false, and the program will exit automatically without printing anything. Okay, so be careful about this situation. So the normal situation is when you print whatever you expect them to be printed, but sometimes you may have an infinite loop. Sometimes you may have a no output. That means there's nothing that shows in the uh, as as outcome. Okay, so this is how we use the for loop. Now let's use, for example, instead of numbers, let's use a string. So let's say we have a string. I'm gonna call it str. It's computer. Okay, so I can print every letter separately using the loop. I'm gonna say start from 0 because computer, the way it is stored in the computer, every letter has an index, and that index starts with 0. It's like a position, or that's that for every letter. So let's say C is occupying index 0 or spot 0, O is 1, M is 2, and so on. That's how the program will recognize every single letter, will access every single letter. I'm saying from 0, which is the index of C, go all the way to the end, depending how long. So that's why I'm going to put str dot length. Length, that means whatever the length is, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 8, and I'm going one letter at a time. Okay, so I have to put the parentheses here. Okay, and you put length, you have to put parentheses at the end. So the length, that means how many letters or characters the string have, which is in our case, it's 8. So here I'm trying to print every single letter separately. So I'm going to put str at, and then I'm going to put the index, which is I. So this will print every. So let's see how it goes. When I run the program, you're going to see that every letter is printed separately. C by itself, O by itself, M by itself. Okay. I can also do it backward. How? Instead of starting from 0, I'm going to start from the end. And what is the end? It's length minus 1. Why? Because if you look at computer, how many characters you have? 1, 2, 3, 4, 5, 6, 7, 8. But when I'm looking at the index, if I start from 0, which is the index of C, then you have C is 0, O is 1, M is 2, 3, 4, 5, 6, 7 is R. But the length is 8, which means the last one is whatever the length is, which is 8, minus 1. So I have to put minus 1. And the difference of 1 is because when we count, we start from 1, but when you use the index, we start from 0. So there is that one difference. So I'm going to put here, I'm going backwards, I'm going to use higher or equal than 0, because that's the last one. And then I'm going to go backward, minus minus. So this will do the same thing, but it's going to print it backward. So if I do this, you're going to see that computer is printed one letter at a time, but backward. R is first, E, and C is the last one because C has index 0. Okay, so that's how the for loop works. All right, now there is something else I can do with the loop. I can add numbers. So let's say I want to add some numbers. Let's say I'm going to go from 1 to 6, and I want to count or add add up all the numbers from 1 to 6. 1 plus 2 plus 3 plus 4 plus 5 plus 6. So I'm going to start from 1, and then of course less or equal than 6, and I'm going to go increment by 1. So I want to add them up. So all I'm going to do, I'm going to put sum. Okay, I don't have to print at this point because I'm counting. I'm going to print at the end. So I'm going to put sum plus equal. Plus equal that means keep adding. That means keep adding 1, 2. So remember, we started from 0. That's the initial value. So if we put plus equal 1, basically what I'm doing is 0 plus 1 plus 2 plus 3, and then the program keeps track of this. It's like you are collecting. Imagine you have an empty bag and you are collecting toys or fruits or whatever, and then you have an empty bag, and then now we have one toy. Okay, what's the total now? 1. I added 2 more toys. The total is 3. I added 3 more toys, now 6, and keep going. So now, if I, yes, so if I'm going to keep adding. Now at the end, that's why I'm going to wait until I'm outside the loop, and then I'm going to print what is the value of sum after adding all these numbers. So I'm going to put the sum is sum. So when I run the program, it's going to show me 0 plus 1 plus 2 plus 3. What is the answer? 21. Okay, 21. So 21 is when you add all the numbers from 1 to 6. As you can see, because I'm using the same thing over and over, so the program keeps adding over and over. Now, since I changes from 1 to 2 to 3 every time you add the next number. Okay? So that's one of the things we can use for the for loop. Now there is another loop. It's called the while loop, and also it's almost similar. Most of the time, it does not really matter which one we use for loop, the while loop, but in some particular situations or circumstances, it is preferred to use one or to choose one rather than the other. Okay. Now I will give you an example about that. So how does the while loop work? The while loop works very similar. They all have the 3 components. I'm going to start with the value first. Let's say I'm going to start from 1. I have to start with this one first. And I'm going to put while. While, probably the best translation for while is as long as. So as long as while I is less or equal than 10, keep printing. Print. Say out I. Now if I run the program the way it is, what's going to happen? The program will keep printing 1 because there is no code to change I to 2 and 3 and 4. So I need the incrementation. As you can see, it's very similar to the for loop. The only difference for the for loop, I have them horizontally, side by side. But for the while loop, I have them vertically on top of each other. But it's the same thing. So look right here, 1 is the initial value. Is 1 less or equal than 10? Yes. Print it and then increment I, add 1, then go back because you're not going to exit the loop until this condition right here is false. So 2, 3, 4, always true. 5, 6. Once you get to 11, that's when this condition is false and then it will exit the loop. Okay, so now if I run the program, as you can see, you're going to get the same numbers from 1 to 10. Okay, 1 to 10. So I can print them vertically if you want to. So run the program, and then you're going to have the numbers from 1 to 10. See that? The same thing. Well, whatever we said about the for loop is applicable to while loop. I can go backward. So I can start from 10, and then again, I need to change this. Now, since I'm going backward, I'm going to end with the small number. So as long as I is higher or equal than 1, keep printing, but this time go backward, minus. So now we're going to get the same thing, but backward, 10, 9, 8, and so on. See that? Now be very careful here. What happens if I change the order? I minus minus, I put it first. What do you think is going to happen? I'll give you a few seconds to think about it. Is it going to affect the outcome, the results, or it doesn't really matter the order? Doesn't matter which one you put. Now, if you think about it, I initial value is 10. Is 10 higher or equal than 1? What's the first step I'm going to do? I'm going to subtract. I minus minus means subtract 1. That means it's not 10 anymore, it's 9. Then you print. That means the first value that will be printed is not 10, it's 9 because I decremented, as you can see right here, then I printed. So now when I get to the end, once I get to 1, which is the last one, 1 is higher than 1, yes, or equal, yes. Then you subtract, which means it becomes 0, and then you print. So what can happen is the first number will be 9, and the last one will be 0. So you have to be careful here about the order because it does make a difference. See that? Now, also I can use it for the sum. Remember, I can also calculate the sum using the while loop. So here I can put, of course, let me change this one back to what it was. And then I'm going to calculate the total. So I'm going to put here sum plus equal I. So that's going to calculate the total from 1. Yeah, it's going for here. It's, yeah. The only thing here is going to add 10 first because I'm going backwards. So it's going to put 10 plus 9 plus 8 and so on. So let me print the total here. Say out. The sum is sum. So what is the value if I add all the numbers? Remember, I'm starting from 10, 9, 8, so I'm adding all these numbers. It's the same thing. It's like just question of order, but it's the same thing whether you start from the bottom or from the top. You're going to get the same thing. So it's 45 if you add up all these numbers. Okay, so that's how the while loop works. I'll give you one example before I end this lecture to use the while loop to show you how sometimes you need to make a choice which one you need to be using. So let's say we have an ATM machine. Okay, we're gonna just kind of simulate the ATM machine transaction. So let's say somebody wants to go to the ATM machine and get money from there. Okay. So first, how can the ATM should give permission, okay, should verify that the person is the owner of the bank account. So let's say there is a PIN number. Let's say just for let's assume that this is the number. Let's say 2378. It's a random. Remember, this number you cannot see it when you run the program. It's hidden. Okay, and then we're gonna have a variable here. Guess is basically whatever number you are trying as a user or the person who is using the ATM machine is gonna try to put a number. We're gonna try to see if it matches with the real one. Okay, so we're gonna start with prompting the user. Enter, please enter the PIN number. That's what you're gonna see when you are using the ATM machine. So of course we are going to save it. And we already have the so just have to use guess equal or CIN guess. Okay, now we're saving it. Now we're gonna use the while loop. We are going to get that statement that I'm sorry, it is invalid as long as the two numbers are different. So as long as these two, that means the real one, 2378, and the guess, whatever the number the user is using, so as long as they are different, as long as the pin is different than guess, then we're going to get the same message that I'm sorry, you cannot log in. So I'm going to say here, as long as it is different, so I'm going to get that statement, sorry, invalid entry. Try again. So this statement will be repeated over and over. So that's what the loop is for, as long as they are different. But you want to give them a chance again. So I'm going to repeat CIN, CIN, CIN. Okay. So they can try for the second time. Hopefully they will get it right. Okay, so this statement, sorry, invalid, will be repeated many times as long as these two numbers, once they are the same, then automatically that's going to exit the loop. And then here I'm going to put, oh, you are logged in. So welcome to your bank. You are logged in successfully, which means there's no way you're going to get this statement unless you get them correct. Because if you get the PIN number wrong, you are stuck in this loop. You're going to keep hearing this statement over and over. You're going to keep trying. It's not the right number. Go back. You're going to get this statement and then try again, try again, try again. The only way you can exit this loop, okay, the while loop, if you get it correct. That's why it's going to show welcome to the back only if you get the number correct, 2378. So let's run the program and see how. Okay, so I'm going to run the program. It's going to say, please enter the PIN number. I'm going to try the wrong one. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Okay, fine. Oh, sorry, invalid entry. Try again. Okay, 6, 7, 8, 9. Oh, sorry. So I'm going to keep having the same statement 5, 6, 7, 8. Sorry, it's not. Now, let me put the right one. 2, 3, 7, 8. So now they are not different. That's going to exit the loop. So now it's going to say, welcome to your bank. You are logged in successfully. All right. So now we covered the for loop, the while loop. This is one of the situations in which the while loop is preferred over the for loop. Okay. But most of the time, it does not really matter which one. Well, thank you for watching this lecture. Let me know if you have any questions. Thank you.